Well, hello and welcome back. This is Joe Brownlee with Palm Beach State College. You are watching the final exam review series for intermediate algebra. We are on question number 39, the home stretch, the last page. So if you've made it this far, congratulations. We can see the light at the end of the tunnel. So let's not delay. Let's jump right in. And the directions for number 39 are actually on the previous page, but let's go ahead and read them. And they are: perform the indicated operation and express in lowest terms. All right, so number 39, and they give us 3 over y squared minus 3y plus 2 plus 7 over y squared minus 1. Alright, so you may recall from earlier in the series when we had a similar problem to this. We are adding these two ratios together, these two fractions. And so when we are adding fractions together and we do not have an equal sign, we are going to stack them and find a common denominator and then combine our numerators. So let's go ahead and do that. Let's go ahead and stack. So we have 3 over y squared minus 3y plus 2, and then we have 7 over y squared minus 1. All right. So the first step to finding a common denominator, because you'll recall that in order to add and subtract fractions we need a common denominator, we are going to want to factor each denominator, because my common denominator has to have the same factors as both of my fractions. Alright, well, let's start with the bottom fraction here, and our denominator here is y squared minus 1. Well, you may recognize that as being the difference of perfect squares, and so that factors as y plus 1 and y minus 1. And then in my upper denominator, we have a trinomial, and this is going to factor. We know it's going to have some y's, but we're looking for factors of 2 that add to give me -3. Well, that's going to be -2 and -1. All right. So now that I've factored both denominators, I have 4 sets of factors. Now, my common denominator has to have each unique factor. And so let's start with our top fraction here. So y minus 2. All right, y minus 1. And if I look down here, well, I don't have a y minus 2, but I know my common denominator has to have a y minus 2, so let's go ahead and add that. I have an y minus 1 here, and I also have a y minus 1 here, so that checks out. That's good. But here I have a y plus 1, but no y plus 1 up here. But remember, we have to have each factor, if it's unique, no matter where it comes from. And so since it was down here, we have to include it as part of our common denominator. All right, and I think that is it. Yes, it is. All right, so now that we've established what our common denominator is going to be, we go back and we look to see whether or not each factor was in our original denominator. Well, y minus 2 checks, y minus 1 checks. Oh, looks like I'm missing my y plus 1. So since I'm missing my y plus 1 in the original, and I added it to my common, really that means I multiplied this denominator by y plus 1 so that it was included as my common. But whatever I do to the bottom, I have to do to the top. And so I have to multiply my numerator by y plus 1 as well, because I multiplied my denominator by y plus 1. Well, what is 3 times y plus 1? Well, 3 times y gives me 3y, and 3 plus 1, or 3 times 1 is just a positive 3. All right. Well, now let's do the same thing here with our second denominator. Y plus 1, that checks. Y minus 1, that checks. Oh, but look, y minus 2 is part of my common denominator, but it was not part of my my denominator rather, in my original second denominator here. So I obviously had to multiply in order to get it as part of my common denominator for the second fraction here. And whatever I do to the top or bottom, I have to do to the top. And so 7 times y minus 2, well, what's 7 times y? That gives me 7y. 7 times negative 2 gives me negative 14. And now that I have a common denominator, I can go ahead and simplify my numerators. So this is going to come over, and I'm going to have 3y plus 3 plus 7y minus 14 over our common denominator of y minus 2, y minus 1, y plus 1. And when I do that, I see that I can combine some like terms in my numerator, 3y and 7y, and positive 3 minus 14. So 3y plus 7y, well, that gives me 10y, and positive 3 minus 14 gives me negative 11 over my common denominator of y minus 2, y minus 1, and y plus 1. And there you have our simplified expression, 10y minus 11 over our common denominator of y minus 2, y minus 1, y plus 1. All right, so let's go ahead and look again real quick to see what we did. First thing we did is, since this is not an equation, it is an expression because there is no equal sign, we stacked our given terms, and we had 3 over y squared minus 3y plus 2 and 7 over y squared minus 1. And so we factored our denominators. And when we factored our denominators, we were able to come up with a common denominator. And the common denominator, remember, has to have each unique factor from each of our fractions. All right, so in this case, we had a y minus 2, a y minus 1, and a y plus 1. Each of those were unique, and so each of them is included in our common denominator. And whatever we multiplied our denominator by, we had to multiply our numerator by. And once we had that common denominator, we were able to simplify our numerator to get to our lowest term simplified expression. All right, well, this was number 39. We're going to move to 40. I hope to see you all there. Again, this is Joe Brownlee with Palm Beach State. Thanks for watching.